All right, so here's our pre-calculus problem of the day. We're doing another problem involving logarithms. And so this will be solving a logarithmic equation. So a lot of these will have the same basic approach. A lot of times, pretty much every time we could kind of write out the steps that we need to do most of these. And I'll start off by pointing out a common mistake that a lot of people might make is we cannot just cancel out the logarithms. So it's not like if you had a 2 in every term in the equation, you could just divide by 2 and get rid of the 2. You can't divide by logarithm and get rid of the logarithm and just have x minus half plus 2 equals 2x, I guess. It doesn't work like that. So first step a lot of times is expand or contract the logarithms. And so once you get to where you have probably a single logarithm on one side, maybe a single logarithm on the other side, maybe not. If you just have one log on one side and just regular algebraic expression on the other, that's fine. But if you have multiple logarithms, are going to need to contract. Most of the time, you're not going to be expanding in equations. Most of the time, you'll be contracting. Then what you need to do, if necessary, is isolate the log on one side or the other, or on both. Well, if it's on both, you don't isolate, but um, isolate the logarithm. So meaning you might need to divide, you might need to do whatever to get the logarithm by itself. So you get the logarithm expression by itself, and then it kind of depends. It kind of depends. So sometimes you might just need to cancel the log at that point or convert to an exponential equation. So it depends. And we'll talk about what it depends on. But those are the three basic steps. Once you get to here, then you probably can just solve the equation as if it was any other equation. Um, a lot of times it's easier to solve an exponential equation than a logarithm equation. So that's why when you get to this step, you might want to convert. But let's see what happens here. So expand or contract, obviously we're going to contract here. So we're going to use those properties that we talked about before. So log of a times b equals log of a plus log of b, or ln in this case. And then we're also going to use log of a to the x equals x times log of a, or in this case, x to the a. So we have the multiplication here. So this is ln of x minus 1 half times 2. And then we're going to bring this up as an exponent. So this will equal ln of x squared. Now, I always say this is not technically correct, but this is what I say. At this point, you can cancel the logs. You're not really canceling the logs. The step you're really doing is this. Now we'll multiply this out. So we have 2x minus 1 equals e to the ln x squared. Now this is actually what you're doing. A lot of times in the class I will say just cancel the logs, but this is really what you're doing. E to the ln and e to the ln. Now e and ln will cancel each other out. And so you have 2x minus 1 equals x squared. Now, I mean, if you skip that step, what did you do? You just kind of canceled out the ln's. Um, but this step here is really what's going on. This is the silent step that you can write out or not. But again, you can only do that if you have ln of one thing equals ln of another thing. If you have ln of this equals ln of that, then the two things that you're taking the log of have to equal each other. If you have this situation, you cannot just say e to the ln, e to the ln, e to the ln, and then cancel them out. That doesn't work. So make sure you contract them first, then you can do the necessary steps to get rid of the ln. Now we just have a regular quadratic equation, so we'll set this equal to 0. And then we can factor it. This would factor into x minus 1 squared, and we get x equals 1. Now this, well, any logarithm equation, the domain of a log function So the domain of ln of x is 0 to infinity. So if you get, a lot of times it's just any negative answer, but really any answer that when you plug it in, you're going to end up taking ln of a negative number, that answer will not work. And that can happen, especially a lot of times if you get a quadratic equation at this point and you get two answers. So in this case, you just got one duplicate answer of one. But if you get like, say, -3 and +1, probably the -3 is not going to be a real answer. It's just going to be the +1. So anytime you solve a logarithm equation, it's probably a good idea to check it. Sometimes they don't have any solution, even though you end up getting one, you get an extraneous solution. Other times you get two solutions, but only one works. So it's always a good idea to check. So let's check this. This is actually pretty easy to check. So we'll plug in 1 for the x, and we'll see if this works. And you actually don't even need a calculator for this if you know your rules of logarithms. So this would be ln of 1/2 plus ln of 2, and then ln of 1 is just going to be 0. So that side is just 0. Now expand this using the other property that we didn't write. So we'll write it here. Log of a over b is log of a minus log of b. And if we do that, we get ln of 1 minus ln of 2 plus ln of 2 equals 0. Of course, these cancel each other out. Ln of 1 is 0, and so we get 0 equals 0. And so that works. So x equals 1 is the solution. So get familiar with the process. Get comfortable with doing these steps. You may or may not have to do both of those. Probably you only have to do one or the other of these, either expand, probably contract, or isolate the logarithm. Um, and then either cancel the log or convert to an exponential, one or the other. So, like most other things in pre-calculus and calculus, every other math class takes practice. The more you practice it, the more comfortable you get. So, if you have any other problems you want me to do, more complicated equations, we can definitely do those. So you can leave those in the comments or send me an email if you got it.